Have you ever wondered why rockets always launch straight up first? Wouldn't it save time if rockets flew sideways immediately?
3, 2, 1.
Actually, launching straight up is the smartest choice. First, rockets must escape Earth's thick atmosphere. The Stern-20, the air near Earth's surface, is extremely dense. That dense air creates enormous drag. Let's compare two different rocket trajectories. Direct vertical ascent minimizes time in the dense atmosphere. Flying sideways at low altitude creates extreme drag and thermal stress. The faster the rocket reaches thinner air, this is where things become easier. We are breaking through the atmosphere. Welcome to orbit. Gravity is constantly pulling the rocket back. Gravity is the single greatest force shaping our universe, so engines spend most of their power fighting gravity. But what if we could manipulate that pull? To reach space, we need incredible power. The first stage burns an enormous amount of fuel. Most of this giant rocket is just propellant. This pushes it through the atmosphere, sometimes over 80% in just a few minutes. In just a few minutes. The empty booster is released. As a rocket climbs, it burns through tons of fuel every second. With the vehicle becoming lighter, the same constant thrust produces a dramatic speeding us toward the stars. Now comes the gravity turn. It finally begins turning sideways. Welcome to our journey. We are climbing higher. See the planet's curve? Notice how thin the atmosphere is. This is our home. Because rockets don't just go to space. To understand how these satellites operate, they must stay in orbit. Orbit requires incredible speed. That's 28,000 kilometers per hour. Objects in orbit might look like they're weightless. They're actually falling around Earth forever. When an object falls fast enough sideways, it falls around the Earth instead of into it. This is orbit. The International Space Station is the perfect example of a constant free fall. From the vertical launch to the gravity turn and finally reaching that perfect orbital velocity. So rockets launch vertically to escape Earth's dense atmosphere quickly. Then they perform a gravity turn, tilting sideways to gain orbital speed. That's how they stay in orbit. For a planet to hold on to its atmosphere, it must fight a constant battle against the solar wind to escape the atmosphere, shaping the evolution of worlds. So the next time you watch a rocket launch, it isn't just going up, it's following the most efficient path into orbit. If you enjoyed this video, don't forget to like, share, and subscribe to the Engineer Sir channel for more amazing science videos. Listen.